Hello, good morning, students. This is second lecture. Already in PUC first year, we have studied types of matter, that is solid, liquid, and gas. Here, in this lecture, we are going to study various types of cubic crystal. There are mainly four types: simple or primitive type, body centered, face centered, and end face center, or it is also called end centered cubic crystals. These four types are mainly depends upon the atom or sphere or molecules occupied on the cube position. Simple or primitive centered cubic lattice means the molecules or spheres attached at the eight corners. Actually, there are eight corners for the cube. Therefore, all the eight corners of cube are occupied by the cell or by the sphere, and hence it is also called simple cube or primitive cubic crystal. Secondly, body centered cube. Body centered in this type, eight corners are occupied by sphere, and apart from eight corners, one molecule or atom or sphere is situated at the center of the cube, and such type is called body centered cube. I can show later the types, the figure of simple body centered, face centered, and end centered cubic lattice. Third type is face centered cube. Face centered cubic lattice means eight corners are situated by sphere, and there are six faces. There are six faces. At the center of face, at center of each face is occupied by sphere, and such type is known as face centered cubic lattice or cubic crystal. Fourth type is end centered cubic lattice, or it is called end face centered cubic lattice. In this crystal type, eight corners are situated by molecules or atom or spheres, and two spheres or molecules are occupied on the face opposite to each another, opposite to one another. Only two faces are occupied. Such type is known as end centered cubic crystal. See here, in this figure, you can see how the molecules or atoms are situated. See, simple cell or primitive type, in this eight corners are situated by molecule or atom. Second is body centered cubic lattice. Here eight corners are occupied, and one full atom, yellow you can see sphere, that is fully occupied at the center of the cell. You can see third type, face centered cubic lattice or cell. Here eight corners are situated by molecule red, and yellow we can see, yellow at the top, bottom, side, adjacent. At the center the molecule is situated on the six faces. And last one, end centered or end face centered cell. You can see here the two yellow molecules or spheres are situated opposite to one another face, opposite to one another. Such type is called end face centered cell. Okay. Now, how to calculate or how many number of atoms are contributed for simple cube, body centered cube, face centered cube, and end centered cube. Here, see here I shown here simple cubic cell. The contribution is 1 atom per unit cell of the simple cube. Body centered cell 2 atoms. Contribution is 2 atoms per unit cell of BCC. Face centered total 4 atoms are contributed per unit cell, and end centered or end face centered cell totally 2 atoms are fully contributed. Now, calculation of number of atoms per unit cell of simple cube, body centered cube, and face centered cube. This is very important. According to point of exam view, for 2 marks problem or question may be asked. How the question will be? Calculate number of atoms per unit cell of simple cube or body centered cube or face centered cube. Let us see here. I have shown figure. Figure is the number of atoms per unit cell is equal to 8. 8 means 8 corners. And at each corner, the contribution of atom is 1/8. Out of 8, 1/8 part is contributed at the each corner. Therefore, 8 into 1 by 8, total 1 atom. 1 atom is fully contributed. See below figure, it is 3-dimension picture, 3-dimension structure. Therefore, how at each corner the atom is contributed. See, I can explain. If you take one lemon and cut its half, again half, and again half, means 1/4 part, 1/8 part of lemon is situated at the corner. Simple cube arrangement is shown here. 52% of space is occupied by the atoms. Polonium is example taken. Now here, calculation of number of atoms per unit cell of body centered cube. Here all the 3 pictures shown 3-dimensionally. Example also given, cesium chloride and cesium bromide. Here 8 corners which is shown by red molecule and yellow molecule, yellow atom, yellow sphere at the center. See a calculation. Number of atoms present per unit cell is equal to 8 into 1 by 8, means 8 corners, and at each corner 1/8 part is contributed, plus 1 atom at the center. So 1 into 1, it will be 2. So totally 2 atoms are contributed for body centered cube. Okay. Now third one, calculation of number of atoms per unit cell of face centered cubic lattice. See here 8 into 1 by 8 will remain same. 6 faces are there, and at each face the contribution of atom or molecule is half inside. Therefore, 6 faces, at each face contribution is 1 by 2. Therefore, 6 into 1 by 2. So it will be 4. 3 plus 1, 4. Total contribution is 4 molecules or 4 atoms. Now here in this slide, atomic radius of cubic lattices calculation is shown. Simple cubic cell R, R means radius is A by 2. For face-centered cubic cell, R radius is A divided by square root of 8. And for body-centered cubic cell, R is equal to square root of 3A by 4, where A is length of the cube. Radius ratio. Relation between the radius, coordination number, and the structural arrangement of the molecule. Radius ratio is equal to radius of cation divided by radius of anion. Greater the radius ratio, larger the size of the cation, and hence the coordination number. To calculate density, there is one formula. Density is equal to ZMA divided by NA into A cube. So detail we can see in calculation part, where MA is mass number, NA is Avogadro number, A is length of the cube, and Z is number of atoms. Number of atom is contribution. For example, simple cube, how many number of moles? 1. Atoms 1. For body centered cube, how many atoms? 2. And for face centered cube, how many total atoms? 4. Like this. Okay. Now here in this slide, some of the molecules radius ratio is given. You can see first 0 to 0.155, coordination number is 2, shape is linear, example is also given. Second, between 0.155, 0.225, coordination number is 3, triangular planar, example is also given. Next, 0.225, 0.414, coordination number is 4, shape is tetrahedral. 0.414, 0.732, coordination number is 6, shape is octahedral. Next, 0.73221, coordination number is 8, body centered cube. Cesium chloride is example. Brevich lattices. There are some parameters of cubic lattice we have to consider. Lengths given A, B, C. Angles alpha, beta, and gamma. There are total crystal lattice 7 and total Brevich lattices are 14. Now, depending upon the length of the cube, there are various types of crystal systems are existing. In this slide, it is shown here. For cubic structure or system, length must be same, A, B, C. A is equal to B is equal to C, and angle is 90. Simple cube, face-centered cube, body-centered cube may exist in this cubic lattice. Octahedral, then tetragonal, monoclinic, triclinic, hexagonal, rhombohedral, or trigonal. So depending upon angle and length, these structures are existing, totally 7. In this slide, we can see how the structure looks like. Crystal systems with unit cell parameter. 7 main types. Thank you.